Okay. So anyone who were kicked out, you just join back in the session. So the session now is recorded. So hopefully this is going to help us more in processing. Okay, I'll just prepare things here. Ay, nako. Markers are not helping. Are you still there?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. You have to bear with me because markers are really, I mean, really sucks. Can you see the screen?
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes, sir.
So, okay. Now, I mean, please be so, I'm really sorry with my diagram. I mean, can you see my whiteboard?
No, sir.
I mean, from the video, I mean, my camera is open. You can check it from my. What about this time? Can you see it?
Half, sir.
This, sir.
I'll just move it later. You just remind me when the part of the board is no longer visible so I can move it later.
All right,
Okay. I
sir.
just really hope that this is going to work. Because at the same time, I'm also displaying the. Or I think I can try also my cell phone for a while. Hoping that this is going to work. Oh, sorry. Color bar. Color bar. Oh, I can tell you. Sorry. Hello? Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
But do you hear me twice like an echo?
No, sir.
Okay, I'll just put down this one. But I hope things are clearer now. What do you think? Is things clearer now?
Yes, sir. Yes, sir.
Yes, sir.
Okay, minimize this one. Okay, but can you still see my window? The one that I am sharing, the screen share?
Yes,
Yes,
sir.
sir. Sir.
Yes,
Yes,
And
sir.
then
sir.
can you see also this one, the whiteboard?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
sir.
Very good.
Yes, sir.
So at least I can do this together. Let me try to use my headset if it's going to work. Okay. So, hello?
Yes, sir. Madungog na ka, sir.
My headset, my earphone is not working. Okay. So we will talk about Alan, can you say something? Alon? Alon, can you say something? Or at least anybody, can you say something just for me to make sure that you are hearing me?
Yes, sir. Yes, sir. Madam.
Sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
I think, sir,
Okay.
nawala si Alan, sir.
I see.
Nako, hello.
Okay, so let's continue. You can mute now your microphone. Okay, so what we're going to start now, we did or we finished already the summation notation and its properties. We will start now with chapter 2, which is organizing data or data organization. We have 30 minutes to do this one. So, okay, there. We will start from frequency table, graphs, and distribution. But actually, we cannot cover the graph now. We'll just keep the graph, but and then the percentile. So from the screen now, you can see there, from the window that I am sharing, you can see the table 2.1, right? Table 2.1 is an example of it's an example of raw data. Okay, so what we have now here is we will try to organize the data set. By the way, when we talk about frequency distribution table is um, one way of data management. Okay, so raw data are simply data that is directly collected from the respondent. And now the moment you organize it, it's no longer raw data. It's like it was already organized. So something was already, it was not the original, shall I say. So looking at table 2.2, the instruction or what we're going to do is we will prepare a frequency distribution for this particular data set. So it says that array the table 2.2 is certainly an improvement, but the table could be made more compact. If the class contained 100 students, an array would be quite difficult to look at. So putting it in this table, actually the score of 25 students was said to be already somehow presentable in this, what we can see from table 2.2. But there is a better way of presenting it instead of using array by means of simple frequency distribution table. This is what you can see now. From table 2.2, we will make a table 2.3, which is this time we will arrange the data. But how do we make this? It's like this. I hope you're seeing this one, right? So we will start from 2 and then 3, 4, 5, 6, 7, 8, 9. Oh, I lack one. Wait. 2, 3, 4, 5, 6, 7, 8, 9. I need one more column. Two, 3, 4, 5, 6, 7, 8, 8, 9, 10. Okay, so this is what we have. By the way, these are the unique scores from the array data. Okay, from the data you can see from table 2.2, I try to identify all the unique marks or score, and those are 2 to 10. Okay, but I just recorded all the unique scores for these are all integers from 2 to 10. Now, the next thing that we will do is actually we'll tally the score. I skip already tallying here. What we're going to do is we will look how many from the array data, how many scores, how many twos are there. So you notice you only have 1, 2, so you have 1. How many threes in the array data or in the 25 scores collected or gathered? How many threes? No, or there is no three. So we will put this 0. Meaning to say the frequency of the mark or the score 3 from our array data of 22, 25 students is 0. No students got 3 as their score. And then for 4, how many 4s were there? There are 4 also. And how many 5? There is only single person who scores 5. And then we have also 5, we have 7, 6 students got a score of 6, and then 3, 5, 2, and 2. So you notice that all in all, these are actually the frequency. We call this now the frequency, a simple frequency distribution table. We actually recorded the frequency of each score. Example, you have a data set of um, 21. Okay, with the data set is, we have 25. So of the 25, how many got a score of 2? How many got a score of 3? How many got, of the 25, how many got a score of 4? So this is now the frequency. This is called simple frequency distribution. Okay, so we have it already in this form. Any question?
None, sir.
Can you see me? Can you see my face while explaining or no?
Makita na, sir.
Okay. So that is the first goal, to come up with a simple frequency distribution. So we've got it already. This is a simple frequency distribution. Now, the next step is we identify the mode. Identifying the mode as defined, mode is simply, of course, we took the frequency distribution, the simple frequency distribution of the data set. Now, after recording it, we will just simply identify the most repeated score. So in this case, if you look at this one, from the frequency, the highest frequency is 7. Okay? So it means to say now that there are, or the mode distribution of this data set is unimodal. Okay? I cannot write it anymore because I only have a limited space. It's called unimodal, meaning to say there is a single score that is most frequently repeated, and that score is 6. So meaning to say, from the 25 students, uh, the most that got a score, or the most repeated score is 6. And there are 7 students of the 25 who got a score of 6. That's the mode distribution. Now, if in case, for example, 8 here happens to have also a frequency of 7, so it means to say that we have a bimodal data, meaning to say the most frequently repeated score in our distribution is actually 2, 6, and 8. That is if this is also 7. Okay? But in this case, since there's only one most frequently reoccurring value, which is 7, which is 6, which we've got a frequency of 7, that's why this is called a unimodal data. Okay? So I hope that's clear. By the way, whenever we get the summation of this one, you notice this symbol? We have this sigma, the summation notation, and then F. So it means to say the summation of the frequency column, the summation of all the frequencies. If we're going to total the two, this is 5, 10, 11, wait, is this even 25? Wait, 10, 20, yeah, it's 25. That is equivalent already to our N, the sample size, or the number of our distribution. So we have 25. That's the summation. That's how we applied now the concept of summation notation. We took the summation of the frequency, which is 25. And if you look at the array table here, we've got 25 scores all in all that were somehow organized in a frequency distribution, simple frequency distribution. So we're good with the mode. By the way, if we have 3 most frequently reoccurring value in a data set, we call it the trimodal data. But beyond that, it's just simply called a multimodal data. Now let's talk about the cumulative frequency. For the cumulative frequency, our main concern sometimes it would we will have the question like, how many students are, like example, you are one of the 24 students or 25 students. Now you wanted your score is 6. Okay, for example, I've got a score of 6. I'm wondering how many perhaps among my classmates, among the 25 or 24 students or classmates I have, including me, that makes me 25, or that makes it 25, how many actually have a score that is lower than my score, which is lower than 6? That would as easily answered if we are going to associate now the concept of cumulative frequency. Accordingly, you can construct a cumulative frequency by simply doing this method. I'm sure for those who were once with me already, you know this. At least you're familiar with this one already because we have this in Math 100. But for the sake of review, and then for others who do not perhaps encounter this one, this is how we're going to do it. By the way, in our slide, or by the way, from the PDF that I am sharing, we don't identify the less than and the greater than CF or cumulative frequency. But I decided to introduce this one. There is actually what we call the greater than CF, or also known as the greater cumulative frequency, and then we have the less than cumulative frequency. The one that you can see from the PDF file is the less than. But I'm going to introduce both because for the purpose that our concern is not just how many students who scored lower than my score. As much as I would like to also introduce to you how to find out as to how many scores happens to be greater than my score. Okay? Because technically, example, if I will identify how many students got score lower than my score, it would somehow create some confusion of identifying the students who got greater than my score, because remember there are also other students who might perhaps have the same score with mine. So that's why I would like to introduce both. Again, this is the greater than CF, and then we have the less than CF. Our point of reading here is the symbol, left to right. So this symbol is read as greater than CF, and this one is less than CF. Now, how do we prepare the two columns? Let's start with the greater than CF. For the greater than CF, for a while, this one starts from the highest score. Now, this is our marks or scores. And then from the highest score, that's 10. If we will start from the greater than CF, we should start from the highest, which is, we record now the frequency of the highest, which is 2. Now, to complete the succeeding boxes here for the greater than CF is like this. 2 plus the next frequency, that's 4. So we record it here, 4. And then next to that is 4, then the next frequency. That's why it's called cumulative. It's just adding subsequently. That we have 9, you have 12, you have 19, you have 20, you have 24, you have 24, and then you have 25. Guaranteed that the last value here would coincide to our the summation of our frequencies, or equivalent to our sample size, or the number of distribution. Otherwise, if this is not so, then there is something wrong here in the middle. Okay? Now, for the less than CF also is the other way around, which we start from the bottom. Here, the frequency is 1. That's the frequency of the score 2. Now, from this here, we move forward. So that's frequency 1 plus 0, the frequency of the second entry, that is 1. 1 plus the third entry, which is 4, that's why we will have 5. 5 plus 1, you have 6. 6 plus 7, you have 13. 13 plus 3, that is 16. 16 plus 5, that is 21. 21 plus 2, that is 23. And then 23 plus 2, that is 25. So still, we end with 25, which is the total number of observations. So now, how do we use this one in interpreting, or to interpret as to how many score? Now, earlier I asked the question, if I am the student and I wanted to find out how many score, or how many students who actually have a score that is lower than mine, so if it's lower, I would refer it from the less than CF. Now, my score is 6. Okay, I'm here. I wanted to find out how many of my classmates happens to have a score lower than my score, which is 6. So what am I going to do now is from here. The cumulative frequency under the column less than cumulative frequency of the score 6, which I belong, is 13. Okay, this is 13. Now, my concern is finding out how many of my classmates whose score is less than 6. Actually, I would look at here. Okay, 6. In other words, to answer the question, how many of my classmates happens to have a score less than 6, there are 6. Because the cumulative frequency below my score, which is 6, is 6. That's why the number of students and the number of my classmates among the 25 of us, there are 6 of my classmates whose score is lower than my score, which is 6. And who are those, or what are those who score? We have one. Okay, one of them got a score of 5, and then 4 of them got a score of 4, and then one of them got a score of 2. And all in all, there are 6 of them whose score is lower than my score, which is 6. When my score is 6, I've got 6 of my classmates whose scores are lower than mine, which is 5, 4, and 2. Those were their scores, 6 of them. Did you understand that? Question, please. Hello?
None, sir.
Okay. If I may ask you the question, uh, let us hear from Okaot. If I'm gonna ask you the question, how many, if I am the students and my score is 10, how many among my classmates whose score is lower than my score if my score is 10? Okaot.
Three? Sure.
How many?
23?
Okay. There are 23 students, or there are 23 of my classmates have a score that is less than my score if my score is 10. One last question. May I hear from who else can I call? Can you just volunteer? Yes, Apeliedo. Apeliedo left us the conference. I thought she is raising her hand. Let's hear from Labadan. Yes, Labadan. If my,
Yes, sir.
my score is 2, how many among my classmates happens to have happens to be lower than my score? My score is 2.
I think there's none, sir.
Okay. In other words, 0, because if my score is 2 and my cumulative frequency is 1, and then there is no more cumulative frequency preceding my cumulative frequency, then that means to say I belong to the group, or I was, or at least I am one of the among the 25 who happens to have the lowest score. Okay? Did you understand now how to interpret the less than CF?
Yes, sir.
Okay, now let's
Yes,
move to the
sir.
greater than CF. The greater than CF, on the other hand, is trying to interpret and find out how many scores happens to be greater than yours. But this time, we will reverse. It's like we are going to make baliktad our interpretation from the less than CF. We will reverse our interpretation. Now, how do we do that? Like, for example, I wanted to find out how many among my classmates happens to have a score greater than my score if my score is 2. Okay, example, I am this person whose score is 2. How many of my students happens to have a score greater than my score? So I would like to refer it. Now, looking at the greater than CF, my cumulative frequency is 25. Now, if I look at this one, I have to refer now above. The preceding cumulative frequency now for mine is actually the one that's going up because our reference now is the greater than CF. So there are 24 students or 24 of my classmates happens to have a score greater than mine. Remember earlier we mentioned that if I am the student whose score is 2 and there is only one frequency under the score 2, it means to say that I was, or at least I am, the students with the lowest score. Now, consequently, I've got 24 students or classmates of mine whose score is greater than mine. Someone is what was the problem? Putol-putol si Sir guys. No. I mean, thank you for notifying Natinga and Bilingan. Okay, let's continue. So one more quick question. Let's see. What about I wanted to find out if my score is 6 and then I've got 6 of my classmates from the 25 of hours whose score is less than my score or lower than my score. How many from my classmates happen to have a score greater than mine if my score is 6? Let's hear. Volunteer, you may raise your hand. Yes, who's Janilyn?
Sir, Jerry Lane, sir.
Jarilyn, go ahead.
12, sir.
Okay, so if I am here and then my greater than CL is 29, that means to say I've got 12 students or 12 classmates of mine who scored greater than my score. Okay, and what are the scores of those students? 7, 8, 9, and 10. In fact, three of the 12 got 7, and then 5 of the 12 got 8, 2 of the 12 got 9, and 10 at the same time. I mean, and also 2 got 10. One last question. What about if I wanted to find out how many among my classmates got a score greater than mine if my score is 10? Volunteer. Yes, bilingan.
None, sir.
Okay, none. Because this is our less than our greater than CF. Meaning to say, this is already I belong already to the group with the highest score. Because the highest score is 10. If my score is 10, I was already in the top. Meaning to say, no more, I mean, no student, no classmate of mine happens to have a score greater than my score. It's because I already belong to the highest score. Okay? So that's how we use the greater than CF and the less than CF and their simple frequency distribution table. Do you have any question for me before I'll proceed? Anyone? Any question?
None so
Wala,
far.
sir.
Okay. So
None, sir.
we have the relative frequency. Accordingly, if I may read to you the relative frequency, although it may be satisfying to know that you scored better than many other students, what usually matters in terms of getting grades is what fraction of the class scored below you. Outscoring 15 students in a class of 25 is pretty good because you beat 3 out of 5 of the class. But having 15 students below you in a class of 100 is not very good because in that case you have outperformed only 3 students of over 20, or at least that's a probability of, or that at least a proportion of 0.15 of the class. So the kind of table that can tell you what fraction of the score are lower than yours is called cumulative relative frequency. Now, what is this cumulative relative frequency? Okay. Now let us look. We'll just add more columns. We will now have the relative frequency RF. Okay, the relative frequency would give you the proportion, or at least the, what was the word? Okay, to tell us the fraction of how many of your classmates that you have outperformed. In other words, how many of your among your classmates that you perform better. Okay? Now, what you can do or how to complete this RF column is basically the formula here is RF is equal to F, the frequency of that row divided by n. Okay? So for example, for the first one, the frequency of this row here is 1. And then the total is 25. So basically that's 1 divided by 25, which is 0.04. I think 0.04 is, yeah. Okay? How to get the 0.04? That's just 2, I mean, rather the frequency of the lowest score, 2, divided by 25, which is the summation of our frequency, that would give you 0.4. And you do that all the way up. Again, so that is 0 divided by 25, that's 0. That's why you've got there 0 for the next entry. The next 4 divided by 25, that is 0.16. What must be the value for the next? Can someone give me that using your own calculation? How should I get, actually in our window here, shared, the value is 0.28. Ay, sorry, this is 0.28, but this one is 0.04. The same with one. Now tell me, who can tell me why the relative frequency for those who got 6 is 0.28? Anyone? Volunteer, you may raise your hand.
Round off.
No.
7 divided by 25, sir.
You,
0.28 ampere.
how come the relative frequency for the row 6 or for students who got 6 is 0.28? Can you please tell me how did we get 20.28?
I think, sir, kay 7 ang frequency sa score na 6, tas 7 divided by 25 kay 0.28.
Okay. That's it. So let's just complete this column. At least that's exactly what you are or what you're supposed to do. That is 0.12 and then followed by 20, 0.20, then 0.08 and 0.08. Okay? So for the proportion, you would then say that at least if you would try to reduce 1 over 25, that's non-reducible already. Meaning to say, you outsmarted the proportion of the class that you outsmarted is 1 over 25, which is, that makes you less performing in the class. Because imagine, you outsmarted 1 out of 100. In fact, you did not outsmart anyone because what happened was you are the lowest. Anyway, that is how things work here. On the other hand, when you say cumulative relative frequency, it's just the cumulative of this column. Okay? How to do that one? The same way how we do it here, we start from 0.04. And then 0.04 plus the next relative frequency, that is still 0.04. 0.04, this one, plus the next cumulative frequency, that is 0.20. What must be the next value here? The next value is 0.28. 0.24. How to get how did we get 0.24 for the cumulative relative frequency for 5, the score 5? Anyone? I just need at least affirmation that you are still following with me.
Plus, sir.
Plus, what have I added?
0.20.
0.20. Ay.
0.20
0.20, sir.
plus 0.04.
Okay, we added 0.2 and then the 0.24, the next relative frequency. Okay? That's why we have now 0.24. And then we just have to complete that all the way. And then let's just complete this column 0.52 and then followed by what's next? 52.64. After 64, we have 84, 0.84. And then you have 0.92, 0.92, 1.0, 1.00. Okay, so that is how we complete the cumulative relative frequency. It's just the cumulative of the relative frequency column. Okay? You notice this is equivalent to 1. Relatively, 1 here pertains to the whole data set, the entire data set, which is, in this case, we have 25 scores all in all. Okay? So, another thing that we can add here is the cumulative percentage distribution. The cumulative frequency, this cumulative percentage distribution, cumulative percentage frequency is simply, we just turn this into percent. Okay? First is, I think we can stop with percentile. First here is we will get, what's that? Cumulative, let's have first the percentage. The percentage distribution or percentage frequency, you just multiply this by 100. So instead of, you will have percentage frequency is equal to F over N times 100%. We just multiply it by 100%. So 0.04 times 100, that is 4%. Okay? And then you have 4%, followed by this is 20%. Is it 20? Yeah.
Yes, sir.
Then this one, sorry. That's not the case. This is for the cumulative already. But this must be 0. Okay, 0 because there is no entry at all because the frequency here is 0. And then 4, that is 16. This is 16%. This is 4%. Then you have 28%, 12%, 20%, 8%, and then you have 8%. And then the total of this one must be, okay, this is now the percentage. In other words, how many percent of the sample or the distribution you have outsmarted? If you are here, if, example 7, if you are asking how many percent, you cannot tell unless we will prepare the cumulative percentage. Okay? Let's just make the cumulative percentage. You have cumulative percentage. The same manner, that is 4%, 4% plus 0, that is still 4%, plus 16, that's 20%, plus 4, that's 24%, 24 plus 28, that is 52%, which is this one. Then you have 64%, then 84%, and then 92%, and then all this is 100%. So the 100% here indicates the entire data set. Now, how do we interpret now this one? For example, 52. How many percent of the distribution you have outsmarted? If your score is 6, it pertains 24% of the distribution is performing lower than your performance. It's because according to our cumulative frequency, 24 is lower than your group where you belong to the 52%. How do we interpret that one using the percentile ranking? It's like this. Instead of being concerned with the percentage at or below a particular score, sometimes you might want to focus on particular percentage and find the score that has that percentile rank. For example, before seeing the result of the diagnosis quiz, a professor might decide that the bottom 20% of the class must receive some remedial training or algebra, regardless of their actual score on the quiz. Now, it's like this. This is the part where percentage or percentile ranking comes in. Like for example, in board examination, they don't use or they're using percentile ranking. If the top got a percentile rank of 92. So that means more or less you belong to that. If you belong to that one, that means to say you perform well. Um, you are on the 92 percentile rank. So the concern here is that 52%. If your score, if this for example, uh, 52% of the result will receive a remedial because they scored their score is not good. So anyone who got a score lower than 52 percentile means to say will receive a remediation. So in this case, this is the 52. All the score who belong whose score is lower than 52% of the distribution must receive a distribution. So if this is the case, all those who score here below, all those who scored below 52 percentile ranking will receive now a remedial because according to your findings, you wanted to give a remediation to the those who scored below 52 ranking or the lower 52 uh, percentage. Okay? It says here, a percentile can be defined as a score that has given PR, the 25th percentile in the score whose PR is 25. In other words, a percentile is the score or at or below which given percentage of the group falls. The most interesting percentiles are either the quartile percentile. Actually, the percentile ranking is also possible because you can the significant percentiles that is being considered in a data set are the quarterly or the quarter percentile like 25, 50%, 75%, and then 80%. Because if you would associate now that one in a what do you call this one? I forgot the graph. I really forgot the graph. I'm really sorry, but anyway, the interquartile range. Interquartile range will just identify you the ranging there is in terms of quarter. 25%, 50%, 75%, 100%. Okay? So basically, this is what we need to talk about for this part of our session. We have the simple frequency distribution. We have the two cumulative frequencies, which are the greater than CF, the less than CF. We have the relative frequency, the cumulative relative frequency, the percentage, and the cumulative uh, percentage frequency. Question.
Sir, excuse me, sir.
Ah,
Naglibog ko, sir. Giyon sa gali pagkuha ang percentage frequency, sir.
this one?
Yes, sir.
And it's here. Percentage frequency is equal to the frequency of that score divided by the sample size multiplied to 100%. So example, my frequency for the first row is 1. 1 divided by 25, which is 0.04 times 100%. That's why I have 4%.
Okay, sir. Thank you.
Any other clarification? You may ask question now. Are you sure you don't have question?
None, sir.
Okay, I think we can end here. If we don't have any more question, then you just wait. I mean, this one, if you wanted to review this, check the discussion once more. I'll just upload this one and then I'll share the link with you via LMS. Okay, I'll just post it there. And then after which is by Thursday, we will have our next quiz and probably I'm going to post it already in the LMS. So the next quiz will be already in the LMS. Okay, which you need to show already your solution if necessary. If you don't have question, now I think I'll have to stop my screen sharing now. I'm sorry. Okay, I'll stop. Where is the screen sharing? You can already open your microphone and then your camera. We're done. Okay, we're done. I hope you enjoyed our session today. Did you enjoy
Thank you,
Thank
our
you,
sir.
session?
sir.
Thank you, sir.
Goodbye. Thank you.
I'm
Thank you,
really
sir.
hungry.
Sir, bye, sir.
Thank you, sir.
Now.
Thank you.
Bye, sir.
Thank you,
Bye,
sir.
sir. Thank you.
Thank you, sir.
Bye.
Thank you,
Bye.
sir. Bye.
Thanks, sir. Bye.
Thank you, sir. Bye.
Leave now.
Bye, sir.